For decades, engineers swore a three-cylinder engine was a recipe for disaster, guaranteed to wreck itself long before it impressed anyone. Yet when a daring outsider ignored the ridicule and put his design to the test, something unbelievable happened. The so-called doomed engine didn't just survive, it pulled harder and ran cleaner than its well-respected rivals. Why was the entire industry so certain it would fail? And how did the reality change everything they thought they knew? In the late 20th century, three-cylinder engines carried a reputation that bordered on comic relief. For most drivers, the idea conjured images of sluggish hatchbacks and bargain basement city cars, not serious machines. The Daihatsu Charade and Geo Metro became punchlines in automotive columns. Reviewers joked that the Metro's three-cylinder sounded like a sewing machine, and if pushed, might vibrate itself into a new zip code. Car magazines called these engines barely adequate and warned buyers to pack earplugs for the highway. In pop culture, owning a triple often meant you'd settled for less power, less refinement, less respect. This stigma didn't just live in the press. On dealership lots, salespeople steered customers away from any car with a three-cylinder badge, quietly suggesting that four cylinders were the minimum for real reliability or comfort. Mechanics repeated the same warnings. Three-cylinder engines are fine for lawnmowers, not for the open road. Even in technical circles, the phrase "it'll shake itself apart" became shorthand for why serious manufacturers stuck with even-numbered engines. The assumption was simple. Three cylinders meant compromise, not innovation. Yet beneath the jokes and dismissals, there was a real technical anxiety fueling the ridicule. Early triples, especially those built for economy cars in the 1980s and the 1990s, struggled with vibration and harshness. Owners complained about dashboard rattles and buzzing mirrors. At stoplights, the engine's uneven pulse could be felt through the steering wheel and pedals. Engineers explained that unlike four cylinders, a three-cylinder engine couldn't balance its internal forces naturally. The result was a constant rocking motion, a kind of mechanical seesaw that stressed mounts and brackets. Over time, this led to stories, sometimes exaggerated, of engines shaking themselves loose or wearing out ahead of schedule. By the early 2000s, the pattern was set. Automotive forums dismissed new three-cylinder models as gutless and better suited for golf carts. When Ford and BMW announced plans to build new high-output triples, skeptics lined up to predict disaster. The old jokes resurfaced, only now aimed at major manufacturers daring to bet on a configuration most had written off as a dead end. For decades, the triple's reputation seemed locked in place, noisy, fragile, and destined for the bottom shelf. The stage was set for someone to prove the doubters wrong. Inside the engineering offices, the debate was never about fashion or fads. It was physics. Veteran powertrain specialists, some with decades spent chasing smoother engines, saw the three-cylinder layout as a mechanical dead end. The problem was not subtle. Every time the crankshaft spun, the engine's own motion tried to twist it out of its mounts. In a four-cylinder engine, pistons move in pairs so their forces cancel out. But with three pistons spaced 120 degrees apart, there is always one working against the other two. This creates a rocking couple, a twisting force that acts like a seesaw anchored in the middle, hammering the engine's bearings and brackets with every revolution. One veteran engineer, known for his bluntness, put it simply: you cannot cheat the math. That rocking force will fatigue your mounts, rattle your brackets, and wear out your bearings before you ever see the warranty expire. For decades, this was not just a theory. Early three-cylinder engines earned their reputation honestly. The constant vibration would loosen bolts, crack exhaust manifolds, and send dashboards buzzing. Mechanics learned to spot the telltale signs: worn-out engine mounts, leaking gaskets, and hairline cracks in the block. These failures rarely showed up in four-cylinder or six-cylinder designs. The physics behind it is clear. Each piston, as it moves up and down, generates an inertial force. In a three-cylinder, the sum of these forces never adds up to zero. Instead, the engine rocks back and forth along its axis, sending a rhythmic pulse through the car's frame. Over time, this motion is not just uncomfortable, it is destructive. Bearings that should last 200,000 miles might show wear in half the time. Mounts designed for steady loads face constant flexing, leading to fatigue and failure. Accessory brackets and exhaust pipes are forced to absorb the shock, often with little success. Even advanced simulation tools in the early 2000s confirmed what older engineers already knew from experience. The stress maps showed hot spots at the crankshaft ends and at the mounting points, exactly where real engines failed. Attempts to fix the problem with heavier flywheels or rubber mounts only shifted the vibration to a different frequency or made the engine feel sluggish and unresponsive. For most of the industry, the lesson was obvious. Three cylinders meant compromise, and compromise meant trouble. No amount of wishful thinking could erase the fundamental imbalance baked into the design. Pressure was mounting inside the glass-walled conference rooms at Ford's European Engineering Center. The year was 2008, and the numbers on the whiteboards told a story nobody wanted to hear. New European Union CO2 fleet targets were coming into force for 2012, and the gap between Ford's projected emissions and the legal limit looked impossible to close with the engines already on the drawing board. Every department felt the heat. Product planners, accountants, and engineers all faced the same reality: miss the target, and Ford would pay millions in fines. Or worse, lose market share to rivals already boasting about their clean, efficient lineups. At the center of these meetings stood a powertrain specialist who refused to accept the safe answers. The proposal on the table was radical. It proposed replacing the familiar four-cylinder with a turbocharged three-cylinder. The idea sounded reckless to some, almost desperate. For decades, three cylinders were written off as underpowered and unrefined, not the kind of engine you would trust to carry a family across Europe. But the maverick engineer kept pushing, convinced that downsizing, if done right, could deliver the torque, power, and efficiency Ford needed to survive the coming regulatory storm. The stakes were not just technical. Budgets for the next generation of engines were already stretched thin, and every new prototype meant pulling resources from other projects. Some executives worried out loud, if this gamble failed, Ford might not just miss its emissions targets, it could fall behind in the global market, risking jobs and reputation. The lead engineer's own standing was on the line. Betting on an unproven three-cylinder, with the company's future at stake, was more than a technical challenge. It was a personal risk, a test of nerve in a room full of skeptics. As the go or no-go decision approached, the mood was tense. The Maverick laid out the case. With turbocharging and new balancing technology, a three-cylinder could be lighter, cheaper, and more efficient than anything in Ford's current lineup. It would not just meet the emissions deadline, it could set a new standard for small engines. The room was divided, but the urgency was real. The only way forward was to try what nobody else dared: build a three-cylinder that could do the work of a four or even a six, and prove the doubters wrong. The decision was made. The radical project got its chance, and the race against the clock began. Every engineer in the room had a theory about vibration, but the lead designer saw the problem differently. Instead of treating the engine as a collection of isolated parts, he approached it as a complete system, a machine where balance, combustion, and even the mounting points had to work together. He believed that the wild, rocking motion of a three-cylinder wasn't a flaw to be patched over, but a force that could be redirected, managed, and even used to the engine's advantage. On paper, the solution started with a counterbalance shaft spinning at 1.5 times the crankshaft's speed. This wasn't a new trick, but the way it was integrated, tuned for the unique harmonics of the triple, went beyond anything found in old textbooks. The designer filed a patent in 2009, stamping his name on a synergy between direct injection, turbocharging, and vibration control. Instead of fighting the engine's natural rhythm, he synchronized the combustion pulses and mechanical forces, letting them cancel each other out across the whole assembly. The result was an engine that didn't just survive its own imbalance, it thrived on it. Mounts were positioned to absorb the last traces of rocking, while the turbo's boost curve was mapped to smooth out power delivery, right where the old engines would have started to shake themselves apart. This wasn't about hiding flaws with rubber bushings or heavy flywheels. It was a holistic approach, treating the engine, transmission, and even the chassis as partners in a carefully balanced dance. Most engineers still saw 3 cylinders as a compromise, but the designer's system-level thinking turned a mechanical liability into a secret weapon. He never talked about part numbers or spec sheets in those early meetings. Instead, he described a vision, an engine that could be lighter, stronger, and more efficient, not in spite of its odd number of cylinders, but because of them. The skeptics wanted proof. The designer was ready to show them. A row of engineers watched as the engine was bolted down, cables snaking from its block to a rack of sensors, and an old-school analog dyno. The technician double-checked every clamp and lead, then nodded to the control booth. The Maverick stood just behind the glass, arms folded, eyes fixed on the readout screen. No one spoke. At idle, the 3-cylinder sounded almost polite, just a faint, even thrum. But as the throttle opened, the note sharpened, rising into a steady, urgent growl. The dyno drum spun faster. Numbers started to crawl across the monitors: torque, fuel flow, vibration. Everyone knew what the skeptics expected: shuddering, wild spikes, maybe a warning light or a thrown belt. Instead, the data held steady. The technician called out the first pull: 14% more drawbar pull than the benchmark 4-cylinder, with vibration readings well below the danger line. On the second run, the fuel meter ticked over, 12% less fuel consumed than the class average. The crowd by the window leaned forward, squinting at the printout as the results came through. The numbers were clear. This so-called self-destructive engine was pulling harder, running smoother, and burning less fuel than any of its rivals. The hush broke with a ripple of disbelief. The Maverick allowed himself a thin smile. The gamble had paid off, not in theory, but in cold, measured numbers. For the first time, the 3-cylinder had proven itself not just on paper, but under the harsh lights and relentless scrutiny of the dyno room. Rival executives wasted no time making their opinions known. Within hours of the test results circulating, statements from competing manufacturers began to surface in the press. One German automaker dismissed the numbers as lab tricks, insisting that real-world conditions would expose the triple's supposed weaknesses. Another called the demonstration a marketing stunt, warning that durability issues would surface once customers pushed the engine beyond the test bench. Industry analysts joined in, questioning whether a 3-cylinder could truly stand up to daily abuse over hundreds of thousands of miles. The skepticism was not confined to words. Legal teams at several companies combed through patent filings, searching for overlaps with their own designs. Between 2012 and 2014, filings that referenced 3-cylinder balancing, turbocharging, and NVH control increased sharply in global patent databases, especially among Ford's closest rivals. Engineers at a major Japanese firm were quoted in trade journals, claiming their own prototypes had solved the same vibration problems years earlier. Meanwhile, rumors spread that at least one European competitor had quietly started an internal review of all recent 3-cylinder innovations, looking for grounds to challenge the new design's originality. For the first time in decades, the The three-cylinder engine was no longer just a technical curiosity. It was a source of legal tension and boardroom debate. Even a few of the most vocal skeptics began to reconsider, realizing that the old assumptions might not hold. The backlash had begun, but so had a race to catch up. Ford's decision to back the three-cylinder engine wasn't just a technical bet. It was a business calculation that paid off in ways the skeptics never saw coming. Within 5 years of launch, over 4 million units powered everything from compact hatchbacks to small SUVs across Europe, Asia, and the Americas. The strategy went beyond just one model. The engine slotted into the Fiesta, Focus, EcoSport, Puma, and even the Transit Courier, each time replacing a heavier, more expensive four-cylinder. Internal cost breakdowns revealed a 27% reduction in parts compared to the outgoing four-cylinder, fewer pistons, rods, bearings, and valves, all translating to lower material and assembly costs. For buyers, that meant lighter cars with better fuel economy and lower sticker prices. For Ford, it meant higher margins and a simpler supply chain. Sales data told the story in black and white. The three-cylinder models consistently outsold their predecessors, often by double-digit percentages in markets where efficiency and cost mattered most. Engineers pointed to a comparison: same or better torque, lower emissions, and a smaller footprint under the hood. The numbers did not just silence the critics, they forced rival automakers to rethink their own engine lineups. The triple was not just surviving, it was winning in the real world. No matter how far the technology has come, the three-cylinder engine still carries a few reminders of its roots. At idle, vibration levels remain about 15% higher than a well-tuned inline-four, even with the latest countermeasures. Some drivers notice a subtle thrum through the steering wheel and pedals when waiting at a stoplight, an echo of the old rocking couple problem that engineers can only minimize, not erase. For most daily commutes, these quirks fade into the background, but in luxury cars or long-haul trucks, that last bit of smoothness still matters. The search for the next breakthrough is already underway. Hybrid drivetrains are quietly rewriting the rulebook, using electric motors to mask low-speed vibration and fill in torque gaps. Some manufacturers are experimenting with three-cylinder engines as range extenders, where their compact size and efficiency outweigh any remaining roughness. Others are pushing boundaries even further, developing two-cylinder prototypes, like a 1.2-liter concept now in bench testing, that promise even lower weight and fewer moving parts, but at the cost of even tougher noise, vibration, and harshness challenges. Every innovation brings new trade-offs. The three-cylinder has proven it can compete. But the quest for refinement and efficiency is far from over. Whether the future belongs to hybrids, radical two-cylinder designs, or something else entirely, the story of small engines continues to evolve, one bold experiment at a time. Today, nearly 1 in 5 new cars sold in Europe features a three-cylinder engine, a configuration once dismissed as unworkable. As manufacturers chase efficiency and rethink what's possible, yesterday's heresy becomes tomorrow's standard. Innovation rarely looks like consensus. Sometimes the future roars in with fewer cylinders and more imagination. What do you think? Will less keep meaning more?